You know, times have really changed, and nowadays it's more about the mess, at least as we are going to learn, the messy field that is. To explain what we mean by that, we're pleased to be able to have Dr. Paul Galpern here from the University of Calgary. Now, Paul's lab at the university researches how to intensify crop production in Western Canada by focusing on the greater field ecosystem, including things like beneficial insects and conditions in the surrounding landscape. And he's really excited about the possibility for win-wins on the prairies, where both the profitability and environmental sustainability objectives can be both achieved at the same time. So we're looking forward to his perspective, and let's welcome Dr. Paul.
Hello, everyone. My name is Paul Galpern, and I'm very excited to be here. Thank you very much for inviting me. And I'm going to talk about our work regarding messy fields and what that means and why keeping it messy might actually be helpful. Let's look at some of the, let's unpack this story for you. All right, so, the question is, can we have it all? We might say, I speak to a bunch of producers and growers in the line of my work, and I ask them, what do you want? And frequently I hear, I need to make a profit at this business, right? This is not news. But there are many out there who tell me also other things, like, I am working to feed the world. I want to minimize my impacts on nature. And others who tell me, I need to protect my crop from harm, but I don't want to poison the soil and water. There are ways through this. There are possibilities for balance, and that's what we call win-wins. And the answers, I'm going to try and make the case today, are out there. Many of you are no doubt aware that those yellow bits on the map are the crop fields of the prairies. If you add up every single yellow dot on that map, it amounts to 520,000 square kilometers. That's the seeded acreage of the Canadian prairie provinces. And if you put them end to end to end, you would cover an area that goes from the northern tip of Scotland to the southern tip of England twice. That's 2 times the area of the UK. And we're not just talking about the whole prairie provinces where there's ranching and where there's farming. This is just the seeded acreage. It's twice the area of the United Kingdom. That's a huge, massive area. And I'd pick on the United Kingdom because I was born there. But what I think the key point, though, is there are answers, there's solutions out there. And what my lab does at the University of Calgary is asks those questions. Where are the solutions out there on the landscape? And can we bring them home to the grower on the ground? Can we bring them back? Can we look at regional questions and bring them back and see what's working out there and where are the opportunities and where are the risks? So when I say the landscape has answers, the answers are out there. And I think we can look at the landscape across Alberta, at least, and we can classify the areas we see broadly into 2 categories. You've got spots where you've got tidy fields, like the pictures here on the left. And then you've got other parts, perhaps up in the parkland, further north of here, where you've got a much more mess. Now, these are 2 sections here. Both these images are to scale, and you can see the outline of the quarter section over here and over here, and you can see just how different these landscapes are from space. Now, down here in the Lethbridge area, southern Alberta, you're going to see a lot more of this kind of thing than you're going to see this. This looks more like the parkland. But nonetheless, there are still opportunities on your fields for mess. And I want to take you through why that mess might actually matter to your bottom line, might actually matter to your profit, and might create opportunities in all those other places that growers care about. So we're looking here at a wetland. This is a wetland just south of Calgary. And in the distance, there's canola in bloom. And if you are looking for opportunities that might be happening here, okay, apologies. If you're looking for opportunities out here on the land, around that wetland, do you see all that grass? That stuff is not tilled, it's not cultivated. It is an opportunity for beneficial insects and arthropods. So in that area, you've got places where natural enemies, such as that beetle, can hang out all season long and later head out into the field where they can do the heavy lifting, offsetting some, not all, some of your crop protection product costs. Crop pests can be eaten by those beetles and spiders that hang out there around the wetland. And then nectar that in the plants that grow around that wetland attract bees and natural enemies from afar, where they can head out into the field and perhaps improve the quality of your canola, if not necessarily the yield. And that stuff can't happen in the field because we have frequent soil disturbance. We might have seed drilling, or in some cases we might have tilling that will make it impossible for these insects to make their homes out there. So I'd like to imagine messy fields and the areas in the field, such as that wetland, as being hotspots, opportunities for these kinds of processes, these ecosystem processes that might make a difference to your bottom line. And we call those things ecosystem services. And a messy field like the one on the bottom left, you're going to see a greater opportunity for pollination services, pest control services. And here's the big one we heard just a few minutes ago in the last speaker. There are also opportunities in those bits of green that aren't your crop for carbon storage. And this isn't a story yet, but folks, it is coming like a train. It is rolling down that track, and it's going to be here in a few years. We're going to start be talking about the value of those bits on your land that aren't cropped because of their potential to store carbon. And are you going to get paid for them? I don't know. But these are the policy topics that need to start being had, and the messy fields are central to that conversation. But also I hear farmers telling me, and I talk to farmers and they say, I don't want those messy things on my field because there are disservices. I'm going to have pests hanging out in there, and I'm going to have weeds, and they're going to come out into my field and cause a mess and reduce my yields and make everything bad. You know what? The data shows that on average, I hear farmers saying, well, I'm not an average farmer. Okay, fine. But on average, this doesn't happen. Okay? Now that's the thing about averages. There's ones that are all the way over here, and there's ones that are all the way over here, and then there's the ones in the middle, and those are the averages. Yes, we call that as scientists variance. Okay? And yes, your field might be one of those variants. Variance, yes, that's a word we're all using these days. It might be one of those either end from the mean, right? But for the most part, we don't see this effect where these messy areas go back and they bring weeds to your crop and increase pests. So let's make an argument. I'm trying to make an argument, and then I'm going to show you the data. The argument is if we retain or restore or create new messy places in our fields, we're just going to leave that wetland where it is. We're not going to drain it, and we're not going to turn it into crop. Or maybe we're going to leave the fence row where it is, and we're not going to extend our field right up to the edge of it. We're going to leave those messy places there, and there is a potential, and I'll show you the data, a potential to deliver pollination and pest control services. Pollination to canola matters a little bit, not a lot. But that pest control to all of your other crops, that could matter a lot. Now, hold on. If that might have a potential to increase your crop yield, okay, heavier seeds per acre, it might also have a potential to offset some of, not all, but some of the costs you are putting in to inputs. And we might be able to see if we look from space, and I'll show you some pictures from space. If we look from space at the land and we see mess, we might be able to associate that mess with higher yields. And my lab's done that. We'll show you. But hold on. Messy places have other advantages. And this is where the bigger story of sustainability and wins for farmers and wins for the environment come in. because those messy places have other values. And I mentioned one already, it's the carbon storage one, but there's all sorts of other things too. There's water regulation, there's the potential to provide habitat, and that's going to matter too. We have all governments across the country talking about nature-based solutions. These terms are increasingly on the lips of the people that make decisions. So your fields could be part of that story. So let's look at this first connection. Do messy places deliver pollination and pest control services? How are they involved? So since 2015, funded by a whole bunch of folks, mostly the Canola Council, my team went out across Alberta. That's all the red dots on the map. We went out across Alberta to look at beneficial insects and arthropods in fields. We went inside fields, we went beside wetlands, we went to pivot corners, we went along fence rows, 335 locations all the way from Grand Prairie down to Tabor. And in those places, we found about almost 200,000 different bugs. Now, when I say bugs, we're not talking pests here. We weren't interested in the pests. We were interested in the beneficials, the beetles, the spiders, the bees, and this is just a sample of the kind of things we saw. So, bees, did you know we had blue bees and orange bees and green bees, and as well as the yellow and black ones in Alberta? That aside, we also found about 40 species of ground beetles and a whole bunch of spiders, and that's what our operation looks like. I've seen pictures of your operations in the last few days. This is what my operation looks like right there in the lab. So the question then is there an evidence in relationship between messy places and delivering pollination and pest control? Well, we can answer the question, messy places do have the bugs that can do those things. They have the natural enemies, they have the bees. Right, but who cares? They have them. Are they getting into the crop where they might cause some trouble or some good stuff? Are they actually getting into the crop? And we call that phenomenon spillover. Is there any evidence they're leaving that wetland or that messy place, getting into the crop where they can pollinate or they can eat the pests, right? Munch on those flea beetles. Is there any opportunity for that to happen? And we tried to test this. At all those places across Alberta we visited since 2015, we set out a series of traps at multiple distances from wetlands, from pivot corners, from field edges. And what we were looking for is this relationship. So this part of the graph here, and I'm going to interpret this slowly, so stick with me here. This is the distance from, let's say, a wetland. So right up against the wetland is here, and this is far away, like 75, 150 meters away. And then this is the count of animals we got, so low and high. So what we were looking for is, as you move away from a wetland, the number of animals, that's things like beetles and spiders and so forth, is going to drop off. Just like a cauldron. Imagine a cauldron bubbling full of insects. It spills over, and as the stuff runs down the sides, it's going to be much more right at the cauldron and less as you move further away. So it's the same idea here, and we were looking for it in bugs. And we did find that. Bumblebees, top right, drops off as you move away from a wetland. Spiders, the same story. We found it in beetles. A little bit more of a complex story. I'm not showing you that picture. But we found generally the same pattern across all of these beneficials. So grower notes, if you're taking notes here, this is the point I want you to take home. Retain messy areas in your fields to keep natural enemies and pollinators close to your crop where they can do the good stuff, okay? Now, which ones to keep, which ones to throw away, that's a decision that you need to make as an individual in your operation. But if you have to make a decision, and if you're on the fence, I often say if you're on the fence about getting rid of those fence rows, don't get rid of them, okay? Because there is an advantage. So, let's go. We've talked about the spillover, but who cares? Who cares if the animals are in the crop? Are they doing anything I care about? Are they affecting my bottom line? Are they going to contribute anything to reducing my input costs? Are they going to do anything to increase the productivity of my crop? And what we might say we're looking for is this thing called a halo. Is that wetland, or is that patch of trees, or is that whatever that isn't crop, is it glowing like a halo of extra richer, higher yields? You know, maybe you can't see it with your eyes. It doesn't look green. But if you look from space with special technology that can capture different wavelengths of light, we can do kind of something just like this, and I'm going to show you what we did. So we're going to ask the question, is there a connection between messy places in your field and yield? So this is how we did it. As many of you no doubt know, that harvesting equipment is 84% of harvesting equipment in Canada, as it turns out, is equipped with precision yield monitors. And so with the help of a number of agronomist contacts across the province, we managed to get in touch with about well over 100 growers who provided us close to 1,000 field years of precision yield data. So we thank all of those cooperators very much for helping us to do this work. And what we did is we connected precision yield maps like the one you see at the top left of your screen. We connected them to satellite imagery. So that's like Sentinel-2, which is a satellite platform circling the Earth constantly. And we asked, can we connect the yields we see on the ground in these almost 1,000 fields, can we connect them to the information we see from space? So we built a model, and if you've ever heard of the term machine learning or artificial intelligence, that's what we did in our lab, connecting all of this big data to one another. And then we went back and we said, let's study Vermilion, Alberta, and the surrounding area, you know, because that's an area where, well, we have a number of colleagues working up there. So let's go up there to Vermilion, and we looked at about 757 canola fields in the Vermilion area. And we looked at them from space. So basically, we are spying on those growers' fields, and we can figure out, not exactly, but pretty closely estimate their yields in their fields and how the yield in their field varies over space. If you didn't know that people like me can do that to your field, we can. So I'm sorry, but it's happening. But we're doing it for good. Okay, so what we found was, this is what we found. We found that evidence for these halos, exactly as we've predicted here. As you move away, this axis here tells us how far you are from the edge of the field, like where the trees are or where the wetland is. And as you move away, this is your yield. So as every grower knows, you know, right at the edge of the field, your crop isn't going to do so well. It could be for all sorts of reasons, you know, more moisture, less moisture, poor soil conditions, whatever. And as you move further into the field, it peaks. And what we find really is this kind of peak, and then it kind of drops off. And we call this peak just a little bit, or about 50 to 100 meters into the field from the edge. We call that evidence of the halo. So if you can imagine starting here at the wetland or the bunch of trees and heading out into the field, your yield is going to peak just in there, and it's going to return to kind of an even point or a mean value as you head out into the field. So this is evidence of a halo, of a boost that these non-crop spaces, things like wetlands and trees, are actually providing to your field. But you know what? If you kept adding trees to your field, you kept adding wetlands to your field, it wouldn't work. For number one, you'd run out of space for your crop. And number two, there can be too much of a good thing. So we looked at that, and as it turns out, there is a balance, right? It's not all mess, you know, no tidy. It turns out there is a balance, and what this figure shows you basically is it's a relationship between how messy is your field and how many other fields do you have nearby. So if your field is, you know, really messy, but you have no other fields nearby, it's just all natural area, maybe grassland, you know, that stuff that situation isn't going to boost your yield as much as having a sweet spot somewhere in the middle. So there's a Goldilocks zone, okay? There's not too hot, not too cold, but the porridge just right, and it's somewhere more than tidy fields are today. Somewhere a little more on that messy continuum. So grower notes. messy field margins can boost yield as long as there are other crop fields adjacent to you. Keep it in the Goldilocks zone. We asked these studies, vermilion in fields, looking at bugs. Can we extend the question across Alberta? And thank you to the Agricultural Finance Services Corporation, the primary crop insurance provider in Alberta. They provided us with 60 million seeded acres of data between 2012 and 2017. Summary data, so I don't know what happened on your particular field, but I know what happened on average across big chunks of counties in Alberta. And we used that information to ask, do we see this halo effect at a much broader scale across Alberta? And we looked at canola, wheat, barley, pea, and oats for about 420 varieties of these crops. Massive big data set. And here's what we found. We found evidence of a halo effect. In other words, messy areas in your field having an effect on yield, a positive effect on yield in canola, wheat, barley, pea, and oat. And this implies something really important to those who doubt me, okay? This implies that weeds and pests, yes, they might be increased a little bit in your field. They might be as a result of these messy areas, or they might not be. But on average, they are not the dominant effect, okay? In fact, it's the boost to yield that is the dominant effect. Now, I don't want to oversell this effect because it isn't big, okay? It isn't going to suddenly bring in tons more money for you, but that's not the point. The point is that it's at least a break-even prospect. We showed that these messy areas pay for themselves in terms of yield lost. In other words, you didn't get to seed that because it was a wetland. They pay for themselves on average across the province in terms of yield loss, and in fact, they might even add might sweeten the deal a tiny bit, okay? So the point is, we're not gonna keep messy fields to make more yields and make more yields, but we might do it if it has other advantages for us. And that's where this last part comes in over here. This potential to deliver carbon storage, habitat, and other sustainability objectives. And as I say, they are coming down the road fast. There is a train coming, and this is an opportunity we need to look at. Work that my lab has done has shown that these, on average, are not a big problem. The opportunity then is up to you. How do you use that? Importantly, this is about social license, right? And it's also about markets for these kinds of services. Who's going to pay you for those services in future? And maybe it's those European buyers that won't take your canola because Canada's industry or Alberta's industry as a whole doesn't meet the threshold for sustainability. And that kind of stuff is coming down the road. So finally, I want to say I see potential for win-wins. Wins for growers in terms of profits, in terms of yields, and wins for all of those other things that growers and the Canadian public care about. Things like environmental sustainability, things like carbon storage opportunities. I think there's a possibility that we all can win in this game, and I think at the center of that is the messy field. Not too much, not too little. Go for the Goldilocks zone, and I want to thank you for listening, and I also want to thank canola growers who have funded a great deal of this research and allowed us to publish it in top scientific journals. So this stuff is going into the international audience, and it's important that we do that because having scientific recognition for this work gives it more credibility. So thanks to canola growers who have supported this work through the Canola Council, and thank you for listening.
Well, thanks, Paul. That's a very intriguing concept, and I know there's been more research going on around wetlands and the benefits they have, but I'm sure that may have generated some questions from among you. I would ask, does the same theory apply to offices? Can I justify a messy office for the same?
A messy office means a tidy, effective mind. I just have to look in my room, my office, you know. My wife shares it with me. She's on the other side of a great big divide, so she can't see my half.
I knew we were kindred spirits. There we go. Okay, anybody have questions? All right, Jeremy, go for it.
The data from 2012 to 2017, was there any fluctuations that you saw in terms of benefit based on how much rainfall?
So the question on the rainfall benefits, or rainfall factor.
Beautiful question. So when we look at yield data across 2012 to 2017, was there any difference due to rainfall or moisture conditions or environment? And yes, in our models, we throw all that stuff in. We throw in environment, we throw in soil, we throw in all sorts of other things. And we thought, I didn't show you the picture, but we've got a beautiful cycle. So we can indicate, of course, the years that did well, where there was higher yields on average, and they correlate also with wet years. So when doing our models, we absolutely control for those things. So great question.
And did you see some differences?
Did we see differences? Well, the point is, yeah, so the reason why we control for them is because we're not looking for those differences. But yes, we did see differences among years, yeah. Please.
Okay, we got back there, yeah.
Mag, we do a fair amount of modeling too, 30 years worth. One of the questions with the halo effect, how do you normalize or take out the impact of snow accumulation that's impacted by these messy spaces near the field edge? Also, on those field edges, historically, they've collected a lot of soil erosion. So the soils are necessarily not the same in those halo areas. So how do you normalize for that?
Fascinating question. So the question is, lots of things are going on beyond the edge of a field. There could be additional moisture because of snow. There could be different soil conditions because they've been treated differently over time. How does that affect the halo? And that is what I would call why is there a halo question rather than is there a halo question. And I presented my work today. I talked about beneficial insects, and I said, maybe there's a connection between beneficial insects and these these yield halos. The fact of the matter is, we did not show that connection between beneficial insect and yield halos. We showed a connection between messy things and the yield halo. So your question is, what causes the yield halo? Is it something about snow accumulation, or is it about history of that area? And my answer to you is, I don't know, but it's probably all of those things, and it's probably different depending on the field, and that's why we need to understand that better. So we've got what I would call the phenomenon, and we've got a possible mechanism, in other words, pollinators, beetles, and so on, or moisture, right? Other ecosystem services, moisture being one, right?
Okay, so that could lead to more research, it sounds like.
Yes, absolutely.
Which keeps you happy. Now, I thought I saw a question over here. Did I? Or was it over here? Ken's got a question. Okay.
Thanks for your presentation. It's very interesting, and I don't doubt the value potential of those messy areas. I am suspect of the error involved in the data analysis, especially with the satellite data. How did you deal with the error component? Because we've been challenged in precision agriculture for many years with poor quality data. How did you analyze the error, and how confident are you in the results?
Right, so any statistical modeling exercise done, whether you're putting people on the moon or you're studying agriculture, there's error in there, right? And that's why we use statistics. Statistics is about managing error. So one of the approaches that we actually innovated with this precision ag data, I had two postdoctoral researchers working on this, and we've done spatiotemporal models. We can talk about these in more detail after, but models that actually that try and control for the errors that we find in the data itself over space and time. And a lot of the stuff we've seen published, at least using precision ag data, don't use this kind of approach. There is lots of error. I will not deny there's tons of error, but the question is the error systematic in a way that would bias or change our conclusions? And we have no evidence that it is systematic. So in all statistics, there's error. Can we put that error in a compartment? And we do that with our models, bam. And we, if you like, we can control for that, and we ask, are we still seeing a signal? And there's no reason to believe that that signal is contaminated or biased by this error. So that's why, that's the process we do in our modeling. Is it perfect? No, but I don't believe it would lead to a conclusion there was a halo effect when there wasn't actually one. It might, it makes it harder to find that effect, but it doesn't necessarily mean it's not there.
Does it have a confidence level? Like, is it just a pattern, or is it just enough to know that there is some sort of effect?
Right, so I can actually share the papers with you in which we talk about the confidence we have in all those numbers. But these are excellent questions. I mean, I want to be challenged on the quality of our research, the quality of our evidence base, and I think it's really important that those questions are asked. And I will say that there is error, but we're still seeing signal.
Great. Okay. Any other questions? If not, thank you, Dr. Paul. Oh, sorry, did I miss one? Go ahead. Yep.
Your messy areas that have the halo effect, are they strictly wetland messy areas, or does the same apply to bush and windbreaks and things like that?
Okay, so we actually looked at that, didn't show you the results. In the studies that we talked about here, we did not have the resolution to start comparing different types of messy areas. Another study that I didn't talk about today, we actually did break it down. What type of messy area and what effect does it have? And it turns out that it differs hugely based on the type of messy area you have. One, perhaps no big surprise to farmers who have been building shelter belts for a century, shelter belts do have a really positive effect on wheat yield, less so on canola, and virtually no effect on peas. There you go.
Okay, don't leave without your custom-made Farming Smarter shoehorn and your thank you card. Thank you very much
for inviting me.
making this a very interesting and challenging topic for us. Dr. Paul Galpern.